In this demonstration, I want to show how you can use a GitOps methodology to deploy, manage, and update applications as well as perform other automation actions across an entire fleet of hypercore-based systems. So in my fleet manager here, I've got a number of clusters. On a subset of them, in this case about 11, I've deployed a virtual machine using Ansible to set up the runner initially that I'm calling pull runners. What these virtual machines are configured to do is go to a predefined Git repository that I've identified here, pull down, make a clone, and take all the playbooks, the tasks, the configuration files that are stored in that, and then apply them to the local runner. And then also one of the things I have them do is update the virtual machine description, which propagates up to Fleet Manager so we can very easily see what's going on. So for example, on this virtual machine here, it's running 2 containers. It was last updated at 15 after the hour, and these are the 2 containers that it's running. So I want to show the repository real briefly. So this actually is available up on a public Git repo. So this is an example that you could use. The main thing that gets executed when this repository is pulled is set up as this local.yaml file. What I want to actually do is make an edit to this. I have a clone. I've used Visual Studio Code here. And I want to just take, I set a variable for a number of applications to say whether they're absent or present. And we want to go ahead and change this to present. And I'll do deploy applications. And for those of you familiar with Git, there's a bunch of different workflows that you could use for pull requests to get approval, things like that. In this case, I'm just going to go ahead and stage and commit and sync that change so that the next time all of these runners pull and clone this repository, run this local.yaml playbook, they're going to see that a number of things have changed. So one of the things, for example, is they're going to deploy this WordPress Docker Compose. And in this case, I've put all the Docker Compose information that I need right in the playbook. So you can see it all right here. And it's using this state variable, which we just changed to present. It's going to deploy another application here, this Gitia. In this case, it's going to use a project source, which is one of these folder here. And so if we look there, it's just a standard Docker Compose file. In this case, it's separate. One of the reasons I wanted to show these different ways is maybe I have a team that is responsible for just this, and part of their release process is they provide the update to the Docker Compose file for this particular application, and that's all they have access to change or commit or so forth, as opposed to other applications. So let's take a look back here. So this is our Fleet Manager view. So what we should see is when these start to apply, and it'll be in about 2 minutes, it'll start. We'll see some additional containers. I know generally it will go to 6. One of the things I did want to show here is you notice most of these are 2. So I had 2 containers, a Portainer Edge Agent and a security AI sensor that were already running and were deployed as part of this repo. So we're just going to add additional containers here. And then in one example here, I have a locally managed container. This OPC router is only running on this virtual machine, so that's why you can see there's already 3. So it'll go to 7 total containers once it applies and updates. Another thing I wanted to point out, just because we are using Fleet Manager here, is there can be a difference between each of these edge sites being able to access the repository and pull information versus just being able to reapply the local information there. So for example, if I went to one of these sites and shut down a container manually or it crashed, even if that site was not able to pull the repository, but still you could set it up to run the playbook, it would restart that container without having any internet connection to pull the repository down or being able to update its status up to Fleet Manager. So all of those things are independent and autonomous. So it's 20 after, so the playbook should start running, and depending on, again, the network connectivity to each site, the amount they take to run, some of them may start to update. I'm going to do a refresh, and generally takes a minute or 2 before we see. And then again, there can be a delay between when the playbooks are actually pulled, when they're run, and then there a slight delay for some of them to propagate up to Fleet Manager. So we can see here the store 2 has updated to 6, and this is the list of applications. And I also put the ports that are exposed. So this cluster has already updated itself here. Let's go ahead and refresh. We'll probably see a few more. Let's see. All right, so again, we see some more have updated, and I guess as I mentioned too here, so I have one particular cluster running here. This is actually the virtual machine. This is what it looks like from the virtual machine perspective. So I can see there's 6 containers running. It was last run. This is when the playbook was last run at 20 after the hour. This is its list of containers. This is what gets propagated up to the Fleet Manager console, and then I also put on the VM console some status information so we can see basically when this last ran and, any status. It's got that same information that's being reported. And one of the things I can show here actually is there are some other things that are being done in this playbook. So for example, that I put a ISO image in my Git repository. So it's actually located right up here. This netboot XYZ ISO. So that automatically gets cloned down to every runner. So every runner has its own local copy of that there, and I made sure that it does 2 things. It uploads those to the media library, so I can have my media library all has that netboot XYZ ISO. And then I do also create I may have more than one of those here. This is the template for the pull runner. So this one is created by that pull runner and managed. So it actually creates and manages a VM. Currently, it says that the state of that should be off. But for example, say I wanted to start that virtual machine, it would actually be as simple. In this case, I know I put that into a task here, and so the power state is off. If I just changed this to start, and check that in. We'll go ahead and do it. I don't know if we'll be here for that demo, but let's go ahead and let's check that start VM. And we'll check that in and commit it at the next interval, which is still 2 minutes away. When it gets to that point in the playbook, in this case, I actually split it out into a role. When it gets to that, so it's later in the process, it will start those virtual machines. So I have these 2 roles, one that manages the media library, in this case, uploading that one ISO image, the other one that manages that netboot VM and would start that up across the fleet. Right, so let's refresh here, and by now I would think most of them that are going to report should have reported. So we can see, again, a whole number of these have now started to report that they're running all 6 containers, and the list of containers that's up here. And some of these, I think, if we drilled into some of these, I know some of the sites are slow. There can be, again, that delay. Let's go ahead and go directly to this cluster. All right, and we can see, if we look at this Ansible, there's 2 actually on here. See, filter on those. This is the one cluster where I have 2 runners running, but we can see they both last ran the playbook at 20 after the hour. So in about a minute, we'll see them run again. This one's got 6 containers running. The other one here was the one that I had manually installed an additional container, that OPC router, so it's also running here. This is the only case in my fleet right now where I have 2 runners running on the same cluster. In all the other cases, they're running on separate infrastructure. But I guess while we are here, this would be a good as place of any to wait the 1 minute and see when it gets to that playbook execution, that virtual machine being started. As a matter of fact, let's go ahead and pull up the runner here. And so we can see it started to pull at 25 after the hour. In this case, we should see more changes when it gets to the end. We'll see a change on this manage netboot template VM. Okay, so we see the netboot template was changed. That's the change that we mark here. And then if we look at the console here, and let's just look at, we can look at 2 things. Let's look at the log. So we started that. All right, and actually, again, because this one had 2 runners running, they both have their own independent copy of the netboot XYZ template virtual machine. And I guess we can also go back here to our VM list. Let me just filter. I know I have some other netboot VMs that are not being managed here. But here we can see the bunch that are configured by the pull runner and have turned on. Some of them are probably still just in the process of updating and or reporting back. But we can see we've started to start those virtual machines across our fleet. And actually, if we look here, yeah, in this case, a whole bunch of them started up. And so, yeah, wanted to show, again, how easy it is to using infrastructure as code in this case, using an approach called GitOps, where all of our changes are tracked, versioned, approved, using a version control system like a Git repository or GitLab. These can be publicly hosted, privately hosted. In this case, this repo is cloud hosted, but also public. Generally, you wouldn't obviously do this for production, but in this case, I wanted to show these examples and be able to share these examples. In my case, I also have the playbooks that deploy and configure the runner. So this is actually the playbook that does require access to the cluster and credentials, but it starts with a just generic Debian cloud image that's downloaded from the internet if it's not already local to your Ansible machine. In this case, I deploy from my Mac. It downloads the virtual disk from the URL. It uploads those to the media library in the cluster, creates a template VM that we then use. Then it here sets it bootable. This is all part of creating the template. Then it creates the runner virtual machine, make sure that the runner has everything that it needs, including Ansible is a key part of this, that it's got the latest versions of Docker, that it installs the collections that are likely to be used. In this case, we're using Scale Computing Hypercore and the community Docker collections. It sets up the cron tab job. So in this case, there's a variable, but it sets up the cron tab job to every 5 minutes, pull the information from the appropriate repository. And then again, there's some other things like setting environment variables. I make sure that the runners themselves have information in environment variables as well as local files of how to access the cluster that they are running on so that they can do some of the cluster management. And then that is basically it. Those workloads are started and managed just like any other virtual machines, and then they're running their containers all locally. So let me quit. Just go ahead and we can see that all those containers are running here, and that is all using GitOps.